So for people that come from far away, how's jet lag doing this time of afternoon? People manage to stay awake. I know when I come from the US, this is the hardest time of the day. So, but let's see if we can talk about things and get some energy in the room here. So Project Eve, if people haven't heard about this stuff, this is really about the computing part of edge computing, right? It's not, sure, everything is networked, but this isn't primarily about networking. What we're trying to do with Project Eve is actually make edge computing effortless, particularly for sort of unattended devices. Places where you have no staff, where definitely no IT staff. And that means making it be both easy as well as robust against failures, as well as secure in these environments. And it's really about the distributed edge. And what I mean by that is it's actually things that are typically running on-prem. In many cases, connectivity is a bit flaky, could be intermittent. It could be, there's cases when people don't want to pay for satellite all the time or limit the bandwidth, so things might be disconnected for days, not being able to reach the internet, but you still want to be able to orchestrate this stuff. In some cases, it's air-gapped, one form or another, restricted connectivity. You have physical security threats. You might have a lot richer I/O. It's not just TCP/IP networking, Ethernet, radios, 5G, but serial ports and other things, right? That might show up in various environments out at the edge. And this project has actually now reached stage 3 in LF Edge, the impact stage. And this is a testament not only to the sort of growth of the community and the technology and all of these things we've done, but also a testament to the amount of deployment and adoption we have seen. And we're not talking about different projects using it, we're actually talking about production deployment. So there's some huge sort of deployments happening across a large number of different vertical markets, technology, automotive, energy of various sorts, oil and gas, utility scale, solar panels, manufacturing, service providers. There's a lot of different places where this stuff actually shows up. And one of the examples of this is just one use case at one user, right? I believe it's one of the largest Kubernetes deployments in the world if you're counting the number of clusters. So typically when you talk about the cloud, they could have lots of different Kubernetes workers in every cluster. At the edge, because people want autonomy, the clusters are typically tiny, right? Could be single node, could be a couple of nodes. So here we have over 10,000 Kubernetes clusters and rapidly growing sort of across the world, right? And one of the other things that we see in this at a very high level is it's sort of this marriage between a very stagnant or slowly evolving operational technology environment, think embedded computing, think sitting on a factory floor, with people wanting the benefits of CI/CD coming from the cloud native, et cetera, and figuring out where these things actually meet. So this is actually why this is a great learning experience to see where we're going to take compute next, where we're going to take the internet next into these various new environments. So the notion that, if you're running a production line in a factory, you're not just going to let the CI/CD pipeline update that stuff without you being in control. There's going to be someone there that needs to approve this stuff. But you still want to be able to use the CI/CD tools, right? You want to make this stuff as easy as possible, but have the right level of checks in this, which is not about technology. It's more about understanding the workflows and the actual larger use cases and the environment, the constraints, et cetera. But Project Eve has been tremendously successful in doing this stuff in terms of getting people to actually use new open source technology in a large range of different deployments. So if you look at what do we see as a user journey here? And in fact, this sort of project journey has been similar. That the users, they might have a typically Windows monolith that's running on some sort of appliance, a machine sitting out at some site. And they see a need to evolve this stuff because they want to be able to leverage the data they have there. They want to be able to leverage AI. They want to be able to do predictive maintenance. There's lots of things they could do if they can get that data, but they sort of can't get it out of that Windows thing that's sitting there because it's, for security reasons, it might not be connected. We've run into cases where they're running Windows XP today, right? So they clearly have an issue with just connecting that. So the first step is taking that and running it in a VM. What people did in the data center like 15, 20 years ago. But then adding a container or two, running analytics, getting some cloud native things, starting the transition of their application and adding new functionality to it. And then maybe they also then say, hey, for security reasons or for connectivity reasons, we need a firewall, we need an SD-WAN solution. So they're bringing in these VNFs into it as well. And then if they need more containers, they might take a Docker Compose approach to this stuff. And down the road, they see that, OK, leveraging Kubernetes and Helm charts, this is where they're moving in the cloud, where everybody's moving in the cloud. So let's use that tool chain and all of that ecosystem, but make sure it actually fits, and you can actually use it at the edge with these specific edge constraints. In other cases, but this is the typical one, in other cases, it might be someone that's sort of built UCPs, right? And they see that, hey, we have an opportunity if we can bring more of the compute side of things here. Does it mean that we're going to run our own containers? Is it going to be the customer's containers that get deployed here? And how can you actually leverage a platform like this to grow from just providing the network functions to actually being able to provide a larger set of functionality out at the edge? So that's sort of where we're at today. In terms of customers and the project. What is actually coming next? Well, there's two things here I wanted to talk about. One is, how do you actually get a higher level of resiliency out at the edge? So if you're running with some sort of process optimization in a factory, well, just like your database, you don't want a single piece of hardware failure to make it die, right? So being able to build small Kubernetes clusters out at the edge and making this stuff be easier. The other one is actually, what does it mean to deploy and operate edge AI in these environments? And there's a range of things from hardware. We're not talking about the high-end, learning thing here. We're talking about inferencing, but using integrated GPUs, a la NVIDIA Jetson, discrete GPUs, as well as where the models actually make sense and you get to sort of sufficiently optimized models, being able to do this on CPUs as well. And why this? Because in many cases, these systems are deployed with an intended hardware lifetime of 7 years. How many generations of NVIDIA GPUs do we go through in 7 years, right? It's more like after a year, you have to replace it because it's obsolete and the software doesn't work optimally anymore. So what's the right spot here? I think that we will see more CPU-based models over time for some use cases. So if we look at edge AI in more detail, what does it mean about actually deploying, operating edge AI? Well, you need to be able to get the infrastructure out there. So you need to have an operating system, an inference engine, et cetera. You need to be able to do model monitoring and lifecycle management of the models. Some of this stuff is going to be more challenging because of connectivity, sort of what bandwidth do you have? EOS enables you to do this stuff in flexible and secure ways, partly because of being able to. So one way that people deploy models is they put the model in an OCI container. But you also have the inference engine in an OCI container, being able to choose where you pull them from so that you can actually do how frequently you update things, how much bandwidth are you using, trade-offs like that by being able to choose different OCI repositories for different things. Having a secure channel between EOS and its controller is a key piece, enables zero trust, et cetera. And then being able to ensure the integrity of the platform using immutable operating systems and remote attestation is a key piece as well, so that you can know that, hey, the device I'm running on, doesn't matter whether you're running AI or some other workload, you actually know that it's running what you expect to do, as opposed to someone has installed some rootkit in the system. But edge AI is also different than cloud AI. In terms of going and updating the models, how often are you going to do this? How do you actually get the data back to retrain your model? One of the things that I think the sort of larger community is just starting to talk about and think about is who owns that data and can you actually trust it? So one thing saying, I have all of the data in the cloud. If it's coming from my operating in my network, if it's somebody like Google that gathers all of this data, or Facebook, Meta, whatever, they sort of have that data. They know they generated data, they can trust it. If I'm selling a bunch of machines to a bunch of you, right, and I want to be able to take the input from those machines sitting in your factories and retrain things, well, maybe you manipulate the data, right? How do I know that you're not trying to mess with me? That is a key thing of understanding what is actually required there, as well as me as, or you in this case, running this machine in your factory. Maybe you don't want this data to be traceable back to you from a privacy perspective, because that's a machine that's sitting in your factory producing your parts. The fact that you bought it from me as a machine builder, sure, that's nice, but you might not want the whole world to know that. So this sort of like data management and ownership and trust and everything here is actually key. So there's actually work going on in the larger, I think more towards the research community, using technologies like confidential computing and hierarchical learning, and figuring out how can I get the best of both worlds. So being able to build on top of this so that you can actually deal with this very distributed notions of data and data management. I think that that's something that we will see a lot of in the near future here, as people start doing edge AI at a larger scale. So, but what about resiliency? As I said, you need to worry about what failures you care about. So in EVOS, from day one, we built in network resiliency. The fact that people might have an Ethernet on site, but they might want to be able to remotely manage things even when that connection is down. So being able to have a fallback to cellular technology, to satellite, et cetera. Next step is, sure, people use solid state storage, so it doesn't fail very often, but if you deploy things for 5-7 years, it might, right? So being able to leverage RAID and the CFS file system for redundancy across drives. So the thing that is not there, or is just coming, is handling node failures. So I have one computer, its power supply, its motherboard dies. What about that? So the thing that we have been working on in the project over the last year or so, it's actually leveraging Kubernetes, both from a compute as well as storage failover. And this is really to ensure that these clusters with 3 nodes are actually autonomous, so that even if you have hardware failures and the internet connection is down, the Kubernetes runtime is actually taking care of all of these failovers, can take care of replacing things, et cetera, doing all of this stuff without the people operating this having to be Kubernetes specialists. So it's really about enabling people that have a workload. Doesn't matter whether that workload is a VNF, right? Or whether that workload is some container that analyzes oil wells. It's all about making it be easy and secure and scalable. So this is actually available in the current master branch in GitHub if you care to go look. And it's also coming in an upcoming LTS release where people can actually go try this stuff out. So please come and join us, whether you care about working on the open source thing in GitHub. People that want to do that are welcome. But the other place where you can actually come and join us and try this stuff out is running it with your applications, whether those applications are open source or closed source. You can try this stuff out. As part of LF Edge, we're hosting a sandbox where you can actually go and try this stuff out. You bring your ruggedized computer, your Raspberry Pi, your hardware, and then you can actually use this stuff to see this is what it means to deploy and operate things running at the edge. So thank you for your time.